VAP number 6, they give you the differential equation, dy dx equals fx over y, and they give you the slope field for this differential equation, and they give you 2 points, and they want you to find the solutions and go through those points. So as you can see, they're already drawn in. This is 0.12, and this is this is 0.12, and this is 0.3, negative 1. So I followed the tangent lines that were on the slope field to create those curves at that point that crossed the point. Part B asks you to write an equation for the tangent line of the solution that passes the 0.12. So we do that by we're given the point, we have our equation, and we can find the slope of that point at that point, and that's 1/2. And with that, we get an equation of y minus 2 equals 1/2 times x minus 1. For part C, they ask us to find the particular solution, x equals f of x, or y equals f of x, to the differential equation with the initial condition of f of 3 equals negative 1. And we have to state the domain. So for C, here's your initial conditions, and we therefore have the 0.3, negative 1. So we have our original differential equation given, which is dy dx equals x over y. We can divide those variables up to be on the same side, and you get y dy equals x dx. We can take the integrals of both sides, and we get 1/2 y squared equals 1/2 x squared plus c. Now we want to solve for c by plugging in the initial point given, and that c turns out to simplifies to negative 4. So we can plug that back into the equation, and then we can solve the equation for y equals. We do this by multiplying by 2, and then we can take the square root of y, and we get the overall equation of y equals the square root of x squared minus 8. So our domain for the equation we found appears to be from about a little less than 3 and negative 3, and the positive and negative infinity from